All right, next we have Steve Coast. Steve is the founder of Openstreetmap. Begun in 2004, it's a volunteer effort to map the world. He now builds other data sets. He'll be speaking today about sustainable open data.
Thank you. How is everyone? Yay, data. So my name's Steve Coast. I started this thing called Openstreetmap in 2004. And I'm going to give you some background on that, because talking to people, I found out that there were actually quite a lot of people that didn't know about it, which was good. Openstreetmap is a project to map the entire world with volunteers and then give the data away for free, just like Wikipedia builds an encyclopedia the same way. The project began with data like this. This is GPS data from 2005, back before the iPhone, when GPS was still relatively hard to get. Now there's lots of GPS data everywhere. It shows people driving around London, where I used to live at the time. And each of those little lines is a courier driving around delivering packages. It's from a company called eCourier, which was one of the first companies to strap GPS and cell phones to their drivers so that you could figure out where packages were. What I'll do is, because it's not looping, I'll go back and describe what's happening on this middle day. This little red thing is about 2 hours worth of data, and then there's 3 separate days that are shown. And we're just about to enter the second day. So in day 2, these guys wake up and they start driving around delivering packages. There's a pause for lunch right there. Then they drive around some more. Then they go home or go to the pub, and then about midnight, they go home from the pub, which is that little burst of activity there. If you aggregate all this data together, you can make a map, and that's what this is. So this is 2 or 3 days of that GPS data to prove the point that we could make a map of London just using this stuff that's almost an exhaust from their primary goal. They're delivering packages, but they also so happen to collect gigantic amounts of GPS data that we can use to turn into a map. The black lines show where people go both multiple days, and the red and the blue show where they're going on just one day. So you can see that they use most of the main arterial roads every single day, of course, but then some days they'll go off to some slightly less traveled roads on the outskirts of London, and sometimes other roads, right? You need more data to make it complete, but it proves the point. And so that was 12 years ago. And today it looks like this. So we've pretty much mapped most of the world as a display map. And that's an important distinction. The display map is something you look at, right? So you look at it, it looks good. To make something navigable, you need more information. You need turn restrictions and one-way streets and so on, which I'll get into in a bit. And you also need addresses, which are highly important. Because turn restrictions, speed limits, things like that, you can get from GPS data. If you aggregate tons and tons of GPS, you can take all the people driving down a freeway and figure out that the speed limit is 55 or whatever it is. So actually, what you actually get is the free flow speed, which is different to the speed limit. Because, for example, in California, all the freeways are 55 miles an hour, but nobody ever drives 55 in California. So you get a different number, but you get one that's representative of what people actually do. Here's what it looks like where we are, right there. So you can see OpenStreetMap isn't just streets, that's the point here. There's lakes, there's parks, there's golf courses, there's buildings. Everything you could possibly imagine can go into OSM. The issue that OSM has, the one that we're going to address in a bit, is that it looks very good, but it's not navigable. In order to make it navigable, as I said, you need all this other metadata, these speed limits, turn restrictions, and so on, and you need all the geocoding. People will go out and voluntarily collect this data, these days using aerial imagery more than GPS, and go and make something that looks very pretty, but going and collecting every single house is very, very boring. It's not quite as fun as putting your favorite park or road or your house on there. So you can go explore, do what you will with OSM. OSM in the United States began with Tiger data. So Tiger is a Census Bureau product that looks like this. Tiger is essentially a map of the US, but it's not super high quality, and it doesn't need to be for their purposes. If you need to figure out where everyone is, how old they are, where they live, and so on, you need a map in order to lay them out, but it doesn't necessarily have to be geographically correct. It has to be logically correct. So it has to be correct that you're in, I don't know, California and you're in San Francisco, but it doesn't need to be, down to sub-centimeter accuracy, which is what you need to drive a car around. Nevertheless, we could still import this into OpenStreetMap. So we pulled all of this data into OSM, and the US was one of the very few countries where any data was available to be pulled in the first place. So it's a little bit washed out, but you can kind of see that there's roads, there's a grid here. This is supposed to be a freeway, this is not a river. OSM colors freeways, autobahns, and motorways blue. This is actually Lake Merritt. So this is in Oakland, just across the bay from San Francisco. And so you pull it into OSM and let people start editing. So there's an editor on the web. They start clicking around and very quickly turn it into something like this. This is about a year after we imported the data. So you can see people have straightened out the geometry. So now the grid is correct. You can see that they've added different classifications of roads. So it's not all just one class like this is here, all just normal roads. They've added secondary and primary roads. They've added transit stations, parking lots. These little red things are footpaths. The freeway's been corrected. One-way streets have been added, and so on, right? So you can pull in this data and let a community go wild with it and very quickly get substantial improvements all the way through to what it looks like today, where there's just far too much to show you, right? In fact, OSM, any particular view of OSM today is not really showing you all the data because there's too much to show you on one screen. There's tons and tons and tons of information. People add in some countries, adding every tree, every base jumping spot. I mean, it just goes on and on. People add huge amounts of data into OSM that they're interested in. In the rest of the world, it was a different story. This is what Germany-ish looked like in 2006. So this is still a year and a half, 2 years after the project started. And it's still mainly a blank slate. There was no large government data to import in most of the world. So in 2006, we pulled this stuff in. So we at least had a coastline. And then you skip forward a year and people have added all the autobahns and some of the secondary roads. And the reason for that was just they're the big macroscopic items. So when we started, it was let's map the biggest things we can and then go down in scale over time. And that's essentially what happened here. You skip forward another year and all the autobahns are correct, the secondary network is there, and then you look in any city or around where there's particularly energetic mappers and there's tons and tons of data, right? So it happens very quickly. So the next thing I'm going to show you is a video of OpenStreetMap's progress in the United States, if I remember correctly, from 2007 to about 2011, something like that, or 2011 to 2013. The reason is that if I showed you a video of what OSM is like today, the activity is so much that there's not a lot to talk about. It's just lots of flashing stuff, as you'll see. But there are some actual things to show you here of OSM getting improved in the US. I don't know if we have audio, but if we do, oh, we do. They added some funky music to this that may or may not play. So this is Tiger being imported. Those are all the states. And then you'll see these various flashes as bots go through all the data and fix stuff. And there were many, many things that got fixed. That's the end of 2008. Most of the fixes you're seeing are along major roads, freeways, things like that. That was national parks being added. And each one of these flashes, for the most part, apart from the systematic things you see, are individuals. It's Manhattan. San Francisco. DC. So as you can kind of see, the project grows and grows over time. Every single one of those flashes was an edit by someone in the map. The systematic things, as I said, when you saw something rolling across the whole US, was one of the various bots. And there were all kinds of things to fix in the original Tiger data. For example, when we initially imported all the data, all of the freeways and the bridges that went over freeways were connected. So if you're routing, you could think you could just go on a bridge, turn right, and jump on the freeway, for example. And that's an artifact of the way that people store geodata. It used to be the normal thing to do that two roads were connected if they shared a point in space. That meant a connection. And so when the importer came along, it thought that these things were connected when they weren't. There were other imports of, for example, the NHD, the National Hydrography Data Set. All the rivers in the US have essentially got imported into OSM, along with lakes, state boundaries, county boundaries, everything you could imagine went in those little flashes. Today, when you see these animations, it's just flash, 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 and there's no real narrative. You don't see Tiger get imported or anything like that. Just lots of activity. But it still shows the point. So one way to describe OSM is as a disruptive technology. And the New York Times, I think it was last year, it might be the year before, leaked a report on innovation that they had produced for their staff internally to describe what innovation was, because it was sort of happening to the New York Times in a negative way for them. And in there, they describe what is disruption, and they have these nice graphs, pretty much taken from Clayton Christensen, The Innovator's Dilemma, which is a great book if you've not read that. And it has these 3 stages to disruption happening to you. The first stage is this line shows you, right? This is your product. Over time, with some quality, it goes up. So the New York Times of 1800, I'm sure, was worse than 1900 and was worse than the 2000 version. It gets better over time. However, there is some minimum customer need of what they need, right? They don't necessarily need the better quality product, even if you keep evolving it and it gets better. And over time, someone else will come along and do something that is lower quality, but over time gets better, up until a point where it reaches the minimum quality need. So Twitter, right? You used to get your news from the New York Times, now you get it from Twitter. Or you used to read the classifieds in your local newspaper, now you use Craigslist. It was lower quality, then it gets better. Suddenly you don't need the thing you used to use anymore. And then what happens is some sort of explosion and the other one dies, which is bad for the first ones that came along. So in a similar way, Openstreetmap was lower quality and has got better over time. Now what you're probably used to is mostly closed maps. So there used to be 2 primary suppliers of maps, both big companies, now owned by, one is here and the other one is owned by TomTom. And they used traditional models to go mapping. So they paid people in big, expensive cars to drive around and collect data. And they got fairly good stuff, except it was incredibly expensive and a logistical nightmare. OSM came along and made lower quality maps, which over time have got much better. Right now, we're about roughly on par with those maps if you exclude geocoding, which is our big downside I'll talk about soon. And OSM got better and better, which just means that people mapping every zoo, every tree, that kind of thing, which means the traditional models die, which is why pretty much Google went out and made their own maps. It's why Waze made their own maps. It's because it's now extremely cheap to do so. If you're Tesla or Facebook or Apple, you can make your own maps very, very quickly today, whereas before it took billions of dollars and tens of thousands of people driving around for years to create a map. Today, I mean, just imagine if Facebook asked you, and they showed you a picture, and they said, where's your house, and what's the house number? They'd have a map of all the houses in the world in 20 minutes or something like that. So these things are getting exponentially quicker and easier to do. We did a lot of this through mapping parties. These were social events where people come together to map somewhere. This is a mapping party in San Francisco. These were a vehicle to try and get people to volunteer, to come along and map together. The first one was held in the Isle of Wight, which is an island off the south coast of England, which itself is an island off the coast of Europe. The Isle of Wight, this is the map that we were allowed to use at the time. The Isle of Wight is roughly diamond-shaped. It's about, I think it's 30 miles across, something like that. And there are 3 primary cities. There's one there, there, and there, or towns, really. And the reason we picked the Isle of Wight as the first mapping party was to prove that we could map an enclosed area. in a weekend. If we'd picked London, everyone has a different definition of what London is. But if you have an island, then if your feet get wet, then you're not on the island anymore. It's a definitional thing. So about 40 people came along, and they all used GPS units to map where they wanted to go. So we're not prescriptive. We don't say, hey, you go map here, you go map here. People go wherever they want, and they self-select. Each of these colors is a different person on here. And you can see that someone actually walked around the coast. They actually did this. These are the ferry tracks, here and here and here. And then in the towns, people would walk around and bike. Outside, these country lanes, people drive and so on. And then you come together, and very rapidly you can make a map, and that's what the map looks like. And so it's kind of whited out on that image, but you get the basic idea. And so they proved the point, and this was 2006. Things have evolved a lot. This was another mapping party that's worth mentioning, because this bypass, this road here, was not open. It was still under construction. And that's what it looked like. But for OpenStreetMap, we're not constrained by the same things as traditional mapping companies. So if you are employing 2 people in a big truck with GPSs and cameras on it, you can't drive down there. But in OSM, you can just illegally bike down it or something, which is what they did to produce this map. So that's an overview of OSM. If you want to read more, I did a book of interviews that you can get on Amazon. But what I want to talk about is this disparity, these differences between open and closed data. And I'll pick on TomTom, but Nokia or there's now many other companies have map data in relation to OSM. So OSM is free and open. You can go download it. You do whatever you want. And as long as you credit where it came from and you give back any changes, you can use OSM data. Traditional data like this, you pay a lot of money and you're not allowed to do very much with it. And by a lot of money, it's millions and millions of dollars, and you can't make the data available. You can only use it on certain devices and so on. It's very complexly licensed. There are these huge trade-offs between the two things. So in closed data, as I've said, expensive, but it's also limited, because when you're driving around a car, you can't get footpaths, for example. It's highly owned, but it also tends to be high, or at least uniform quality of known quantities. So they know what they're mapping. Whereas in OSM, because you can map anything, I don't know what you're going to map. That controlled environment has a lot of benefits as opposed to open, which is free. There's lots of data. It's not very defensible, because what I mean by that is because it has this variable in quality, I can't give you a defensible case for the quality of the data itself. There are unexpected upsides. If you're really interested in trees, every tree in Germany is mapped with what type of tree it is and how old it is, those kinds of things. And it's kind of directionless. So if I want to tell all of you to go out and map this parking lot, you're not going to do it. But if I am TomTom and I pay people, they are going to do it, right? There are these trade-offs. So the question for me is there a third way? Because the major downside to OpenStreetMap, or open stuff in general, is this directionlessness. That in OSM looks beautiful, but we don't have any of that geocoding data. We don't have your house number in OSM, is what it basically comes down to. And even if I made a really great case for OpenStreetMappers to go do that, they pretty much won't, because mapping every house is just boring, as opposed to all the other interesting stuff on a map that you get to see. I think it really is as simple as house numbers don't appear on the map, but I might be wrong. So by sustainable, I don't mean sort of save the world, organic, or handcrafted. It's more this. Now, I don't think Wikipedia is sustainable, and pick a time frame, 100 years or something, or 50 years or 20. It's not sustainable if you have to put a face and a personal thing on there, every 3 months asking you for $1. That's not sustainable to me, right? You could just put Google ads on there at the same thing, probably make more money, and everyone would be more happy. Are there ways to fund open data and open content and open source that don't rely on these two extremes, right? And in software, we've seen that exists, right? So the big comparison that's usually made is between Windows and Linux. But more specifically, there's a nicer example between Oracle and Postgres. So Oracle, big expensive database, Postgres, big free database and there's a bunch of trade-offs between them. And the question is there a middle way between the two? Because Postgres is quite complicated, just like Oracle. And what happened was this thing called MySQL existed. And MySQL was semi-open. You can download it under GPL version blah, But if you wanted a proprietary license to the code, you could get that too. It was what's called dual licensed. So Postgres was totally open. Go get the code, do whatever you want. But you couldn't tell the developers what to do, right? Oracle, you could pay them millions of dollars and you could get service and support, but there was no thing in the middle, and MySQL sprang up to help that, right? And so in the same way that this has happened for software multiple times now, you can think of Red Hat and other places. Can we do the same thing for data, right? Data, helpfully represented by these cylinders here. There's open data and closed. Is there some third way in between? And so I started blogging about this last year in a post about licenses specifically, that could we create licenses that had some sort of time bomb in them, that they started off as closed. So I give you all this data and you can do whatever you want with it so long as it's non-commercial for the first year. But then after a year, maybe it drops into an easier license and then eventually drops into the public domain over time. So that you have some opportunity, some limited time to go and monetize this thing, to charge people for the data, go fix stuff, but over time it still helps the public domain, or some other open license that you want. Because even Openstreetmap doesn't help the public domain. Openstreetmap, all the data sits in the open database license, which is something that I helped start. And it will sit in the open database license effectively forever, unless there's some big change. Whereas even copyright law, in theory, books will drop out of copyright and into the public domain. They actually don't anymore, but that's the theory. So could we do this with some sort of license hack? Now, it turned out time bomb was not a very positive image to use for this. In fact, someone else came up with it and blogged about this just recently and said exactly the same thing. It's like, well, maybe I shouldn't call it time bomb, maybe eventually open. So I called it license ascent or license descent, because you start in a very restricted environment and then it gets more open. He called it time bomb and then eventually open, which I quite like. And then just recently, the founder of MySQL, who now runs another company doing another SQL database based on MySQL called MariaDB, has done exactly the same thing with Mariah. They're trying to keep it proprietary, and then it drops down into GPL v3 over time. Now, the interesting thing about GPL v3 is it's usually complicated enough that no company wants to touch it with a poll anyway. But anyway, so other people are having this idea is the point. Hence, open geocodes. So OpenStreetMap, as I said, misses all that geocoding information, and Open Geocodes is a project to try and get it all back. So in the US, we've processed and imported a huge amount of data. We have, I think, 93 million records for the US. And if you go to Open Geocodes, it's opengeo.codes. You can see a map of where you are, and each of these green pins has been verified by walking around, and the red pins are imported data. And there's a little activity feed to see what's going on. And in fact, you can see here, for example, this is where we are. This is the hotel complex. The hotel, the way addresses work is usually the location of the building or the entrance or the driveway is projected onto the road. So you have the road coming through here, and then the nearest point on the building projected is apparently ended up there, and similarly for these buildings. So you can walk around with an app, which we're just about to ship on iOS and Android, and collect this data. It looks very boring. It's going to get better. It's predictive, which I'll describe in a second. But basically, you step outside, and it already knows that the nearest thing you're at is 12777 Fair Lake Circle, which is here. You tap on it, and the data gets updated, and the pin gets moved to where you were, which is the entrance to the car park right there. So it's very, very simple. And this app will guess where you are, and as you enter data, will guess where you're going to be, because it knows if you enter two even numbers and the numbers are going up, that the next one is likely to be an even number, e.g. on the same side of the house. So it starts predicting. It gets very easy to walk along and tap, tap, tap. So it becomes very cheap if you're going to pay someone to collect this data, and it becomes semi-enjoyable if you're going to get a volunteer to try and come and collect this stuff and update it. Similarly, there's a sister project to this called OpenGeoIP. Now, GeoIP is similar to addresses, but instead of a street address and a location, we're collecting IP addresses and locations. So at the moment, it's a fairly simple model that just takes the Class C address, so the first three numbers of an IPv4 address, and just says 68.194.101.star is over here. So we actually have the fourth part, but we throw that away, or sort of throw it. We don't show it to you, it's slightly different. to high privacy a little bit, and then we have that location. And we have data all around the world, and we paid Mechanical Turkers to go collect this stuff, and then we give this stuff away for free. So to reiterate, the two projects, you can download all this address data if you want. You just can't use it commercially right now. And you can download all of our IP data in the same way. And now that these base databases are there, the question is how to fill them up with lots of data, either via volunteers or useful projects. So one example of that is, you probably all seen this, where your phone or your browser, some website like a newspaper, for example, wants to know where you are, yes or no. And what they're asking for is the operating system to supply the location, usually based off GPS, Wi-Fi, or cellular, to the browser, which will supply it to the website, right? So let's pretend the New York Times pops up and says, can you share your location? And you hit, yes or no. And people say no because they don't want to share it, and they say yes because they want to see advertising or whatever it is. The problem with this interface is that if you hit allow on a phone, the browser is going to get highly accurate data. It's going to get where you are to within 30 feet or 100 feet or whatever it is. If you hit no, you get nothing at all. So you get this huge disparity. So we have a little API that people have started using that fills in the middle. That if you say yes, it grabs your location, gives it to the browser, but it also updates our IP database. If they hit no, then it falls back to our database and supplies that transparently to the browser. And there's a nice little API to do that. And similarly, we're building more and more things to make this easier. A thing that we're about to ship as well is a popular use case for finding my IP is people stalking, basically, or law enforcement doing stuff. And there are a number of websites which tend to be kind of horrible to find your IP. So if you go on Google and you go and type, find an IP address, there are 5 or 10 websites that will supply this to you, often in a horrible form and trying to get your email address and a bunch of stuff. We're just going to expose it all and have the nicest way of finding IP addresses. And do it in such a way that every time you request an IP address, you also have to give yours so that there's a feedback loop here. So that app that I showed you on iOS and Android, of course the data is going into OpenGeoCode. So you walk around and it's going in there. But you can notice that you can also take that data and put it in OpenGeoIP. Because when you're walking around and you've got the location, I can also get the IP address, and now I'm updating both databases. So I'm trying to find ways of creating these sort of virtuous cycles where you're getting 2 or 3 times as much data and interlinking these 3 things. So another app we have that's backed by Image Identify, which is both a website and also a function in the Wolfram language, is an app that you just simply point the camera at something and it will guess what it is using that API. And if it's wrong, like if that was not a pen, you could just hit doesn't seem right, hit report, tell it what it is, and then we grab all that data as well. And the idea is to use that in a third project. So the next thing we're doing is basically an open source Yelp. So in the same way that Yelp has reviews and places and addresses, if you have an open source version, the address database should just be OpenGeocodes. Every time someone does something, we can also update the IP database, and when people take a photo of their spaghetti and say spaghetti, that should just go into the photo database as well. And then the fourth thing you get out of this, of course, is points of interest. Because one of the other things that's missing in open data is where all the restaurants and bars and so on are. That data that tends to change a fair amount is not in the same data sets. So again, all that stuff is available for download. If you want to know more, just email me. Thanks for your time.